Okay, in this lesson, as we start chapter 11, what we're going to do is we're going to talk about uh, finding arc lengths or pieces of the circumference, and then we'll eventually get to sector area, and we'll extend this into volume of three-dimensional shapes. But for today, your lesson is broken up into two videos. This first one, I'm going to talk about radians and how they relate to measuring angles. And then on your next video, you're going to actually use radians and degrees to calculate arc length. So this first part is just related to the circumference. You don't necessarily need to fill it out. We did it previously last lesson. So just remember circumference, right? Distance around the circle. We use the radius to help us find that. And we practiced last time putting things in exact form. Notice exact form, we leave the pi. And then approximate form, right? We put it into the calculator. And we came out with a decimal value that we rounded. So we are going to use those ideas today. Okay. The arc length is just a fraction of the circumference. So it's a piece of the circumference, meaning that if we have a circle here and we want to find just this much of the circumference, right, we're just finding that arc right there. So the next one you'll actually talk about, the next video you'll talk about arc length and how to find that. So let's talk about what a radian is. Now, a radian is just another way to measure an angle. So if we talk about relating measurements like feet or inches or meters or measuring things like that, it's just another term of measurement. A radian is very similar. Okay. Now, if you look at degrees, if we were to ask the question, right, so I'm going to look at this left circle, why are there 360 degrees in a circle? If you were to think about that, the answer, I don't know, right? Why was it chosen that 360 degrees is what we get to call a circle? Now, there are a lot of different theories. One of the theories being 360 degrees has so many different divisors, meaning it divides by a lot of different numbers nicely. So if I wanted to split this circle up into pieces, right, I could divide it pretty nicely. If I wanted to figure out what a fourth of the circle would be, I know that this is going to be like 90 degrees, right? If I want to know what half of the circle would be, oh, not bad. That's 180 degrees, right? And it divides really nicely up into 4 pieces. This would be 270 degrees. And if I called this 0 degrees, right, that hadn't moved anywhere. But we can create those. 360 actually has 24 different divisors that divide really nicely into it, right? Another theory is it relates to the lunar calendar and the solar calendar, related to about 365 or 355 days. So there's a lot of different reasons. But essentially we could go through and we could say, well, we can split this up into a lot of pieces, right? If I cut this in half, well, half of 90 is 45 degrees, so we could create a little 45 degree angle. I can measure and relate these in degrees all the way around, and we're most comfortable with degrees because that's what we were introduced to first. Radians are just another way to measure, but instead of using an arbitrary degree that we really don't understand why 360 would be thrown into a circle, radians actually relate specifically to the length. So for example, this length right here that I'm labeling in green, this is just your radius length, right? And I'm going to write it off to the side for this one first. Then I'll come back to the other one. Radians allow us, and it's named, right, radian, because it relates specifically to that radius. So if you were to take this radius right here, and again measure it in string, kind of like we did with the circumference, if you were to lay one of those on the outside so that it's also length r, you would have created, right, this would be what we would call an angle measure of 1 radian, and that means that there was 1 radius length on the outside. Okay, now if you were to do another one, and you were to calculate this, there's another 1 radian, right? Now this whole thing, so this whole length would be 2 radians big or long. And this angle right here we would call 2 radians. Okay, and it continues, and we could go all the way around, and actually when you get to this point, what we would call 180 degrees, you've hit pi radians. So notice that would be a little more than 3, or in other words, like 3.14 takes us that far. Okay, so for example, if the length of this is 4, and I move 1 radian along this circle, then I know that this is length 4. If I move 2 radians, well, that's just 2 of those radius lengths, so that whole thing would be 8. If I go 3 radians, right, then that whole thing would be 4 plus 4 plus 4, and this whole thing would be 12. So we can measure with radians just a little bit easier as far as lengths. Okay, now let's think about really quick what that kind of looks like. If I'm dealing with a circle, and let's say I know that straight across, right, all the way across, if this is 0 and I go around the circle, half of the circle is pi. That means if I were to go all the way around the circle, so this length would be pi, this length all the way around the circle would be 2 pi. Right? That would just take me half. That would take me the rest of the way. So when we talk about radians, instead of 360 degrees, we're talking about 2 pi. That's the length around. And radians are generally left with that pi symbol there. Okay, now if we were to take half of pi, right, that's the same thing as half of pi, or in other words, pi halves. We could take a fourth of that, or sorry, half of that, and that would be a fourth. So it's just another way to measure. But we're putting it in terms of pi instead of degrees. So we're going to practice converting between and then talk about how you recognize the difference between the two. So let's say we're looking at converting from degrees into radians, okay? So what we do is we just take the angle measure, whatever the angle measure is, and I'm going to write that off to the side so you remember that. And we call theta, right? That's our Greek letter that we use for angles the most. So if this is in degrees, it's my little degree symbol, all we do is we need to multiply it by pi over 180. Okay, and that allows us to convert it into radians. If we're going backwards, the cool thing about this is then you just multiply by the reciprocal. So let's say we take this theta, and this time this is our radians. Okay, we would just multiply that by 180 degrees, and then we would divide out the pi, because we're turning it back into degrees. We could use those formulas. So let's use those just a little bit here. We're going to practice with that initially. So on number 4, we've got 270 degrees here, and we want to convert that into radians. So we're just going to take that angle measure, and we're going to multiply it by pi over 180. Now, we leave radians in exact form, so we're not actually going to plug pi into the calculator. You can plug the numerical values, so this would be like 270 on the top, right, with pi over 180, if we multiply that. This part, you can go ahead and put into your calculator and simplify. So if I put 270 in my calculator, and then I put divided by, right, 180, then remember we can do math, enter, and it changes it into a fraction. That will give me a fraction value that's just simplified. So when we do that, then we end up with 3/2 pi. You could simplify it by hand if you'd like to, right? Those zeros go away, and then we just know that 9 goes into 27 3 times, so that's the 3 on top. 9 goes into the 18 2 times, so that's on the bottom. Okay, let's do a couple more of these. Again, you could jump ahead and try them. Again, if we're going into degrees, we multiply it by pi over 180, and then we convert that into radians. So that's the same thing as like 60 pi and 180. So I'm going to simplify this one by hand. So again, when it ends in zeros, right, those zeros go away. In this case, 6 goes into 6 once, so this becomes a 1, this becomes a 3. So really we've got 1/3 pi, or usually we just write pi over 3. Okay. Same thing with that next one if you'd like to work through 135. Going the other direction, so I'm going to jump over here to number 6. This one we have pi thirds, and we want to convert it back into degrees. So again, we take our radian measure, whatever that is, and we multiply it by, this time, 180 over pi. Now notice when you do that, the pi's are going to cancel. So you're converting it back into degrees. So really you just have 180 over 3. And if you plug 180 and divide it by 3, you end up with 60 degrees. Okay, notice those are exact opposites. So right there you just converted back and forth from pi thirds and 60 degrees. All right, let's do one more of those. Number 8, so 4 pi over 5. Again, if we multiply it by 180 over pi, notice that our pi's, we've got 1 on top, 1 on bottom. Those are going to cancel. So on the top, you've got 4 times, you got to times it by the 180, and then we divide by 5. So when we do that, we end up with 144 degrees. Okay. The best way for me to remember it is I remember if I'm in radians, there's already a pi involved. I know that I want the pi on the bottom of this fraction that I'm multiplying by so that those will cancel out. So you've got to come up with how you can kind of memorize if it's pi over 180 or 180 over pi. The last thing that we just need to be able to recognize, so when you're finding arc length and sector area, like you will in the next video, is how do I know? How do I know whether it's in radians or degrees? So essentially, if you look up at these, this is going to kind of tell you that, right? Clearly this one's in degrees because it's marked degree. So it's really important that we just understand, right? Degrees, they are going to be marked with a degree symbol. Okay, and that symbol just looks like that little circle, right? We know that that means degrees. So it's really important you understand we're marking that if it's in degrees. Radians then, how do we know if it's in radians? Radian measures essentially will have pi involved, so like pi fourths. So one thing that you look for is look for pi. Okay. Sometimes you'll have it written like radians next to it. Another symbol, if it was like 1.4 radians, so sometimes you don't see pi. Sometimes a C symbol is used. That's confusing only because it looks a lot like the degree symbol, so we don't use that one as much. If anything, just go ahead and write 3 pi radians. Okay. Otherwise, when I look at an angle measure, if I see a pi involved, I know that that's in radians. If there's not a degree symbol, I'm assuming that it's going to be written in radians. Okay. So for the first part of your assignment, you're going to practice with radians, converting back and forth. Again, using these two formulas, just make sure you're very comfortable with going back and forth and simplifying.